Here we'll quickly demonstrate how we can make use of the MS Excel software in demonstrating multicollinearity problem and also doing some analysis. Blood pressure as our independent variable, as our dependent variable rather, which is y, and age as our independent variable, weight also as our independent variable, the duration of the high blood pressure as the independent variable, pulse as our independent variable, and also stress as our independent variable. You could see that we are having 1, 2, 3, 4, 5 independent variable for this particular work. So what do we do? To start with, we'll first have to use the software to analyze the regression model. So we come to data here, we click on data, you come to data analysis here, then from this you look for regression. So this is regression, you click on OK here, then here comes this dialog box. This is where we have to input our y, and this is our y. You pick it from the label to the last value, then you come here to select input x, which is the independent variable. You also select all the independent variable. You click on label because we are interested in how this labeling to shows in the result we are going to be given. We are also interested in the confidence interval. So there are other varieties of statistics which you might be interested in your own. You can click on them, but we'll be okay with what we have selected so far. You can also determine where you want your result to be post or to be output. If you want the output on the same page, you just click where you have it, but I would prefer we have it on a new worksheet. So I click on this and I click OK to give the result. So this is the result in a new page. So let's look at the result. Alright, so let's look at our R squared. Our R squared here is 0.994, which approximately we could put at 0.99. It's quite a very impressive result, which this is trying to tell us that our model can explain the 99% of what is happening in Y. So let's look at the analysis of variance table. This is the regression sum of square. The regression sum of square is 556.89, and the total sum of square is 560. You can find that the total sum of square total is 560, and our regression model could be able to cater for 556.89. That's quite huge. So we only have just 3 out of 560 that our model cannot say anything about. So we can say that the model also is showing to be significant. The model is statistically significant. This is a very good result, which is suggesting from the outlook of the result initially that each of the independent variables we use in our model, they are useful, and that's why we're able to have up a high R squared, a very huge sum of square regression. But let's now check the test statistics, which will tell us how the individual independent variable is doing. So let's look at age. For age, we have relatively quite small standard error, but more interested in is the statistically significancy of the age. So we can find that the age